So 1.8, we're separating it into two parts. Part 1 just goes over solving absolute value equations. When we're doing these absolute value equations, the whole idea with these is to isolate the absolute value and then turn it into two equations and solve both of them separately. With all of these equations, again, the first thing you do is to isolate the absolute value. So if we look at the first example, we have the absolute value of 2x minus 5 is equal to 3. Your absolute value is isolated, so separate this into two equations. When you separate this into two equations, you're going to have the positive of the answer as well as the negative of the answer. You want to keep in mind with these, the absolute value of anything is always a positive number. So if you absolutely have nothing on the same side as that absolute value and it's equal to a negative number, automatically it's no solution. It's not possible. The absolute value of anything is always a positive number. So if it's ever equal to a negative number, it's automatically no solution. So again, this one we're good because it's equal to a positive 3. So when we separate this, we're going to have the 2x minus 5 is equal to, switch the sign on the answer, negative 3, as well as 2x minus 5, keep the answer the same, is equal to 3. So we're literally just taking the opposite as well as the same of the answer and getting rid of those absolute value bars. The reason why you do this is because you want to tell what all that answer can be. So you want all possible solutions here. You got to think, if you have something inside the absolute value bars, that number, when you take the absolute value of it, is always going to be positive. But the number that's inside the absolute value bars can either be a positive or a negative of that number. So the number inside the absolute value bars that's going to give you a 3 when you take the absolute value of that number can either be a positive 3 or a negative 3. Okay? So from here, since we separated them, we no longer have the absolute value bars around this expression. We are going to solve for x. So we're just going to add that 5 to each side, starting with the one on the left. We have 2x is equal to 2, and then we divide each side by that 2. So x is equal to 1. With the equation on the right, again, we're going to add that 5 to each side. We have 2x is equal to 8. We divide each side by that 2, and we get that x is also equal to 4. So your two solutions here are 1 and 4. For example 2, we have the absolute value of 5x is equal to 20. Your absolute value is isolated, so separate it into two equations. It's equal to a positive number, which is why we're continuing. So we're going to have 5x is equal to negative 20, as well as 5x is equal to positive 20. On the equation on the left, we're just going to divide each side by that 5. We get that x is equal to negative 4. Do the same with the equation on the right. We get that x is equal to positive 4. So we have two solutions, once again, negative 4 and positive 4. The absolute value of negative 3x is equal to 10. The absolute value is isolated. It's equal to a positive number, so separate it into two inequalities. So we're going to have negative 3x is equal to negative 10, and negative 3x is equal to positive 10. Divide each side by that negative 3. Remember, a negative divided by a negative is a positive, so x is equal. You can leave it 10 over 3. Divide this one by the negative 3. Keep the negative up top, so it's going to be negative 10 over 3. You just have the 10 over 3 and the negative 10 over 3. If you wanted to rewrite these as just plus or minus 10 over 3, you could do that as well. It means the same exact thing. For number 4, we have 5 times the absolute value of x plus 3 is equal to 28. So with this one, we're going to start it by subtracting that 3. So again, you always want to undo the addition or subtraction before you undo the multiplication or division. So we subtract 3 from each side. You have 5 times the absolute value of x is equal to 25. That absolute value is still not isolated, so we're going to divide each side by that 5. Remember, when you have a number directly in front of a set of parentheses or the absolute value, it means multiplication. So to move that number to the other side, you want to divide each side by that number. So we have the absolute value of x is equal to 5. Your absolute value is now isolated, so separate this into two equations. We're going to have x is equal to negative 5, as well as x is equal to positive 5. For example 5, we have the absolute value of x minus 3 is equal to 2. So our absolute value is isolated. Again, separate it into 2. So x minus 3 is equal to negative 2. X minus 3 is equal to positive 2. I'm going to move that 3 over by adding it to both sides. So we have that x is equal to 1 and x is equal to 5. For example 6, we have the absolute value of 2x minus 3 is equal to 7. So again, our absolute value is isolated. It's equal to a positive number. So we're going to separate this for 2x minus 3 is equal to negative 7, as well as 2x minus 3 is equal to positive 7. We want to add that 3 to both sides. We're going to have 2x is equal to negative 4. Then we divide each side by that 2, and we get that x is equal to negative 2. For the other equation, again, add that 3 to both sides. We get 2x is equal to 10, and then we divide each side by that 2, so x is equal to 5. So negative 2 and 5 are your solutions for this one. For example 7, we have the absolute value of 2x minus 3 is equal to 11. So again, absolute value is isolated. It's equal to a positive number, separated into 2. So we have 2x minus 3 is equal to negative 11, as well as 2x minus 3 is equal to positive 11. I add that 3 to both sides. So we have 2x is equal to negative 8. Then we divide each side by that 2, and x is equal to negative 4. For the 2x minus 3 is equal to positive 11, I add the 3 to each side. So I have 2x is equal to 14. And then I just divide each side by that 2, so x is equal to 7. So negative 4 and 7 are your solutions for this one. For number 8, we have 4 minus the absolute value of 3x plus 6 is equal to 1. So with this one, that 4 is separated from the absolute value with that negative sign. So that negative sign right in front of the absolute value means negative 1 times the absolute value of that 3x plus 6. So we want to move that 4 over first. So it is positive. The opposite of a positive is a negative. So again, we're just going to subtract that 4 from each side. We get a negative times the absolute value. So the opposite of the absolute value of 3x plus 6 is equal to negative 3. We divide each side by that negative 1. These become positive. So it's the absolute value of 3x plus 6 is equal to a positive 3. Our absolute value is now isolated. It's equal to a positive number, so separate it into two equations. So we're going to have 3x plus 6 is equal to negative 3, as well as 3x plus 6 is equal to positive 3. We're going to subtract that 6 from each side. We get 3x is equal to negative 9. Then we divide each side by that 3, and x is equal to negative 3. For the other one, subtract the 6 from each side. We get 3x is equal to negative 3, and then divide each side by the 3, and you have that x is equal to negative 1. For example 9, we have 3 times the absolute value of x plus 5 plus 6 is equal to 15. For this one, I'm going to start by subtracting the 6 from each side. We get 3 times the absolute value of x plus 5 is equal to 9. Then we just divide each side by the 3. We get the absolute value of x plus 5 is equal to 3. Absolute value is isolated. It's equal to a positive number, so we separate into 2. So x plus 5 is equal to negative 3, as well as x plus 5 is equal to positive 3. We move the 5 over by subtracting it from each side. So x is equal to negative 8, and x is equal to negative 2. For number 10, we have 20 plus the absolute value of 2x minus 4 is equal to 15. For this one, that 20 is going to get moved over by subtracting it from each side. And you're left with the absolute value of 2x minus 4 is equal to negative 5. Your absolute value is isolated, however, it's equal to a negative number. So because it's equal to that negative number, it's automatically no solution. So again, you cannot have the absolute value of anything be equal to a negative number. For example 11, you have the absolute value of x minus 1 is equal to the absolute value of 3x plus 2. Now, when you have this to where the absolute value is on both sides of your equal sign, you cannot isolate the absolute value. So you leave it on both sides. However, when you rewrite it, you're going to write parentheses around these two. So this is like saying that you have x minus 1 is equal to 3x plus 2. However, when you write this as two equations, one's going to have a negative in front of this parentheses on that 3x plus 2, and the other one is just going to be the x minus 1 is equal to a positive 3x plus 2. Okay, so working with the one on the left, that you put that negative in front of those parentheses on the 3x plus 2. Distribute the negative in. You have x minus 1 is equal to negative 3x minus 2. Now solve for x. I'm going to move that 3x over by adding it to both sides. I get 4x minus 1 is equal to negative 2. Then I add the 1 to both sides. I get 4x is equal to negative 1. From here, I just divide by 4 on each side, and I have that x is equal to negative 1/4. That's one solution. For the other, I'm going to get rid of those parentheses and just do x minus 1 is equal to 3x plus 2. I'm going to move the 3x over by subtracting it from each side, just like I did with the other equation, but I'm going to have negative 2x minus 1 is equal to 2. From here, I add the 1 to each side, so I have negative 2x is equal to 3. And then I divide each side by that negative 2 to get that x is also equal to a negative 3/2. For example 12, you're given the absolute value of x plus 3 is equal to the absolute value of 2x plus 1. So again, we're going to rewrite this. One that's just the x plus 3 is equal to a negative times 2x plus 1, as well as the x plus 3 is equal to the 2x plus 1. So one of them we're distributing a negative into the 2x plus 1. The other one we're just keeping it the way that it is. So working with the one on the left first, I'm going to distribute that negative in. I get x plus 3 is equal to a negative 2x minus 1. I add the 2x to each side. So 3x plus 3 is equal to negative 1. I subtract the 3 from each side. We have 3x is equal to negative 4. And then we divide each side by that 3 to get that x is equal to negative 4/3. For the one on my right, I have the x plus 3 is equal to 2x plus 1. I'm just going to rewrite this without the parentheses. And then I'm going to subtract over that 2x. So I'm going to have negative x plus 3 is equal to 1. I subtract the 3 from each side, and I have negative x is equal to negative 2. I divide each side by that negative 1 now to get x to be positive, and I have that x is also equal to a positive 2.